back about the need for standardizing CICD observability. How do we do that? There was a special interest group formed in it, and you can get a good amount of history, but also like the cool things we've accomplished and the things where we're going forward into accomplishing from the KubeCon talk, which is on the CNCF YouTube channel. But I did just want to provide this because the way we've integrated for that specific KubeCon demo, the way we got some of the telemetry is all through OpenTelemetry using the standards that have been driven by the CICD special interest group, as well as components that are in the OpenTelemetry collector space. So we will talk about some of, let me zoom in a little bit. This is probably pretty small. We will talk about some of the semantic conventions for CICD metrics themselves, particularly the VCS metrics. You can see these in the semantic conventions. They've been in here since I think like 1.27. And then we're also going to talk about a little bit the OpenTelemetry collector GitHub receiver component, which is what's getting this information and putting it into SigNoz. I'm a fan of any OTLP compliant backend because I'm a fan of OTLP, right? So let's talk about the demo that's actually hosted. We had a need, especially with regards to this demo, where we wanted to be able to show these semantic conventions in action, right? Like it's great to talk about the theoretical, but until you see it and use it, how much benefit does it actually provide, right? You're not going to get the value out of it until you get to use it, until it's made tangible. So for the KubeCon 2025 demo that we did, we wanted to show those standards being sent over OTLP into two different backends. So we chose one as a SaaS, which was Honeycomb, and the other we wanted to make sure we self-hosted it. And I have a personal preference of not wanting to store my telemetry in multiple different backends in terms of like the actual databases, right? I want to be able to have all my different signals in one single database. SigNoz uses ClickHouse under the hood for the storage, which is an OLAP database. For me, that was a no-brainer. I was like, okay, great. Like I can self-host this at the edge in a K3S cluster and have like the certain idiosyncrasies that I have met because it's using ClickHouse under the hood. And it, pretty easy to create visualizations in. So great, I've got data going into both different places, one single collector, right? Well, actually it's two collectors, but the data is coming through those two collectors into both database backends at the same time. This, as mentioned, is self-hosted. This is on my actual personal site. We'll probably migrate this later on, but it's it's running inside of a K3S cluster that's not actually exposed to the internet. I'm using some Cloudflare zero trust magic to be able to make this visible to everyone on the internet with some rules in place. But let's actually show what the telemetry is in here, right? What does it actually look like? So is that fairly visible? Like, is that easy to read on the screen right now, the SigNoz page? I zoomed in a little bit.
Yeah, it's visible.
Yeah.
Okay, fantastic. So the first thing this isn't the first thing, but this is the first place I'm gonna go to, which is the dashboards. We have two different dashboards primarily in here. We have the GitHub action tracing dashboards and the VCS metrics dashboards, okay? So I think most people are probably interested in traces these days because you can derive metrics from those traces. So let's take a look at that first. The scenario that we had inside of OpenTelemetry, or inside of our KubeCon talk, was about an increase in latency for various different, CI/CD action runs, right? There was actually two issues in the last 3 weeks about, hey, all of a sudden we're seeing like our runners queue in a specific project. Is this happening across the board in the community? We're not sure, right? Something is going on. And I think that's a pretty common scenario from a platform engineering perspective, right? Let's say you're a platform engineer in a company and you provide the fundamental infrastructure to run all of your pipelines on, but also you provide shared pipelines that people can use and just point to, and they can have their builds run, their deploys run, whatever it may be, right? How do you apply SRE fundamentals to those things? Well, it's not really a solved solution in the industry, right? But that's where CI/CD observability and the semantic conventions and standards around that really come into play, right? Because you can start to use those semantic conventions no matter what vendor you're in, no matter what utilities you're using, right? Whether it be Argo CD or a GitHub pipeline or a GitLab pipeline or a Tecton pipeline, right? If they match this convention, then you can make those. You can observe all those things consistently and analyze them very, very well. So, one of the questions was like, hey, are we seeing this across the board? The normal way you'd have to do that is you'd have to go in and you have to say, okay, let me go to this repo. Let me go look at this action. What's it look like? Great. Let me go to the next repo. And you'd have to do this long-winded, path of figuring out what's going on. Well, or you could just observe it. That's the alternative, right? Actually get information from your traces. And so this is just showing the P50 duration. There's actually because this happened again, so there's a new issue in the community saying, hey, can we get some more runner time? Here's the information of it. I had other dashboards that were P75, and then of course you could do P05 to understand actually what those outliers are. But here we can see if we zoom into this area. Let's see. So look at the last 6 weeks. I'm gonna see if I can find a spot. We've also added a lot more data in here. But you can see that a good amount of things are below the 10-minute mark. But we have some really long spikes. We do. Why is that? Well, these, as you can see here, are the load tests, right? The load tests, they run for a bit of time. That's consistently the case, right? These are just long singular jobs that run for about an hour. What we care about is really the jobs that aren't supposed to run for an hour, right? But feel like they are. So in the P50 and in the P75, if you were to look at it, or at the P05, you'd be able to quickly, determine that most jobs on a good day are going to run, in under 10 minutes. Whereas we've got a few different areas where spikes feel like they're a little higher. What's going on with that, right? In fact, what's today, the 16th? I think the spike that they were looking at the other day was in this area. Because things started to run a little bit longer. So again, of course, you can filter down to specific repositories. So if I just wanted to look at, I did the wrong thing. Let's always do the wrong thing. There we go. If I just wanted to look at the OpenTelemetry collector contrib repository, I could do that. And of course, you could build all sorts of visualizations off of that, right? The same thing can be said too for this little calculation. I built this in about 2 minutes this morning. So kudos to making it easy to build visualizations and figure that stuff out. But I just want to understand okay, what is the average runtime for pipelines within a specific repo grouped by the CI/CD pipeline name attribute, right? Took me 2 minutes to build. I've already got the information. Fantastic, right? I can start to understand. Again, as a platform engineer, you may want to say, well, okay, what are the usages of the shared workflows that we have? Who are using them from a product adoption perspective? If you're treating your platform as a product, you can start to make those kinds of queries and analyses as well. So just very, very simple, easy to do. And then we'll take a look at, real quickly, the traces themselves, right? So again, I'm going to filter down to the OpenTelemetry collector contrib repository. Let's look at let's see, let's look at, let's group by pipeline name. And I only want to look at root pipelines. So I'm going to say parent trace ID. Yeah. Parent span ID. That's not the thing I wanted. There we go. Parent span ID not exists, right? I think that's it. Yep. Okay. Cool. Not what I wanted. There we go. Connected. All right, so this is going to show me all of the like fundamental top level traces, right? Like I don't want to look at the little job spans and whatnot. I want to look at the entirety of the trace. So that's why I just removed the parent span not exists. So I'm looking at service name. We're just looking at traces here, right? If I look at, I don't know why that's not, let's see here. Oh, here we go. That's why it was the group by. Let's take a look at some of the traces. So load test is the really long one. I actually want to look at a specific one. I like build and test a lot. So build and test. Let's look at those traces. Okay, so, again, I can come in here, and if I was looking for outliers, right, and I wanted to see a specific trace, I could come in and take a look there. But this is what that trace looks like. 1,600 spans, that's quite a bit. And you can see this is all coming from, the actual pipeline that's running inside of a GitHub action, right? The way we do this is we just have a collector running. It's using the GitHub receiver. Events are subscribed to that come from GitHub. We convert those into spans that are semantically compliant. So very simple stuff. And of course, if I wanted to look at that, like actually the job that ran this, I could go ahead and use the attribute, jump right into it, right? It allows you to apply fundamental troubleshooting things directly to your pipelines. Now let's look at the other dashboard that we created for the demo, which is kind of like I love the traces. The traces are definitely my favorite, but this has a special place in my heart because of the origin in which they came from, which I'll go to in a minute. But, I mentioned this at the KubeCon talk. There is a really great talk by Martin Thwaites, who's a DevRel at Honeycomb. He gave a talk on OpenTelemetry. What is this OpenTelemetry thing? And he made a joke about like the amount of time it takes for semantic conventions to get done, right? When you have 30 engineers in a room talking about how to name something, it's going to take a while, right? Well, now we can actually see how long it will take. So built this, again, another easy to build dashboard, looking at the last 6 weeks, and we're looking at the semantic conventions repository. So, how much time does it take to get a change in? Well, again, we can analyze that very quickly and effectively. So I've got some averages here. Again, averages do include outliers, right? So they may be skewed. The metrics themselves, these are post-computated metrics. The metrics themselves are in singular. I think they run in seconds. So we're just doing some averages across all of those raw metrics that exist. But we can understand like what the average time to merge is, what the average time to approve a pull request is, and how many open changes there are in a repository. You can also group by contributor and so forth, right? You can start to create all different visualizations. I really have a preference for looking at histogram distribution, so I've appreciated that this panel functionality was here in SigNoz, because what I want to understand is like, hey, it may be okay that we have very old branches, but what's the distribution of that, right? Are they mostly, or are changes mostly, or branches mostly sitting in the like smaller section, or do we have like a ton of things out here in the long section, right? Those histogram distribution panels are, I find, to be very effective to understanding like actually how good is this, right? What is the health? I can see a number, but what's the distribution of that number? So I quite like that ability. And again, you can filter by the same attributes, right? All of these semantic conventions, all of this telemetry, and this is where the VCS metrics largely come from. I mentioned them in the semantic conventions, but realistically what they are precursors or leading indicators to DORA capability metrics, right? So all this telemetry that we're talking about here are a way to standardize on your CICD observability, but also provide a very good standard for how you can start to calculate like DORA metrics, right? If you want to understand the number of deployments that are going on, like your deployment frequency as an example, well, you could derive that from your traces, right? If your traces include a deployment piece of information, then you could easily calculate that. And that's where the semantic conventions come in. We have, deployment specific attributes that can be attached to a span that tell you, hey, this thing was a deployment. This is what was deployed, right? In which case, you can just use that telemetry natively to calculate DORA metrics, right? So, and that's the DORA 4. These are the DORA capability metrics. So they talk about things like trunk-based development, small batch delivery. Those are leading indicators to the DORA 4. They help show how effective those things might be towards those 4 key metrics. But again, very easy to just visualize, operate with, troubleshoot, use, analyze, tell narratives and stories about, right? To figure out where you want to go to from here. So I think that's the gist of the demo. Hopefully that made sense, resonated. I don't want to take up too much time, but would love if anyone has questions or comments or things they want to see, feel free to ask.
Cool, I guess. Thank you so much, Adriel.
We have a question from Karthik, Adriel. Karthik is asking, is there any default DORA metrics which can be scraped from GitHub via the GitHub receiver?
The DORA 4, no. The DORA 4 do not get scraped from GitHub via the GitHub receiver. There's a reason for that. In part, like when you're scraping, it's taxing on the API, right? GitHub has significant amounts of limits. Of course, that's what exponential backoff's for, and GitHub app authentication is for to help alleviate. But the scraping side of the house is a lot more difficult to do. And you do need 3 specific types of events. You need that which may not come from GitHub, right? To be able to calculate the DORA 4. Deployments will come from GitHub, in the event everything's hooked up there. Changes, you may be using a Jira as your ticketing system, right? Instead of GitHub issues. So depending on where that lives, that's a whole other piece of data you have to get. And you have to understand the fundamentals of like how that maps to a deployment. And then same thing for merge requests, right? Or I'm sorry, incidents was the Jira thing. Merge request was the change in GitHub. So I got that backwards. That's why we don't scrape them because they're just very hard to calculate correctly. However, you can totally take the GitHub events and hook that up into what is it called? Like also Jira. You can take the Jira events and you can very quickly put them in an OpenTelemetry collector, run them through OTTL, make them semantic, and then calculate and derive those metrics in real time from the event stream. So that's actually the way I prefer to do those things. And with the GitHub receiver, eventually the goal is to be able to automatically handle all those events that will come through there, make them semantic for you so you don't even have to run OTTL statements in a collector. But I will throw up a gist in the future because we, at the company that I work for, we have a backstage plugin for DORA metrics, which is all based off of OpenTelemetry giving you the data from GitHub and making that semantics. I'll put a gist up there in the future for how you can get that directly from GitHub, the events, to make them semantic and then calculate the metrics. This is a great question.